In this video, we're going to talk about phase changes. Now, before we go much further, I want to review the properties in general of solids, liquids, and gases, the three phases that we're going to be talking about. And solids, in terms of shape and volume, we say solids have defined shape and defined volume. In the particle movement of solids, we describe their movement as vibrational. The particles vibrate, but they're kind of locked in place with respect to all the other atoms and molecules. The kinetic energy of solids is the lowest of all the phases, and the solids they exist at the lowest temperatures of all three phases. The particle distance for solids, they are very close together, and typically they have the highest density of all the phases. In most cases, there is one example of a very common substance in which the solid is less dense than the liquid. Now, liquids, they also have defined volume, but they have an indefinite shape. They take the shape of their container. If I have 20 milliliters of water in a beaker and I pour him into a graduated cylinder, then the water will take the shape of the graduated cylinder, but it will still be 20 milliliters of water. The particle movement, we say that the particles now are able to flow. They can slide past each other. And I say the kinetic energy of liquids is, quote, medium, that it's not the lowest kinetic energy, nor is it the highest kinetic energy. From a particle distance standpoint, the particles are at what I call a Goldilocks distance. It's just right. They have some intermolecular forces, but they're able to slide past each other. They're not locked in place. But these intermolecular forces still keep these particles linked to each other, and usually they're less dense than solids, but more dense than gases, with the exception of at least one very, very common substance. Gases, we talked about gases last unit. From a shape and volume standpoint, they have indefinite shape and indefinite volume. They will expand to fill their container. Their movement is very fast. They have the highest kinetic energy of all the phases, and therefore they exist at the highest temperatures. The particles are very, very far apart, and they have the lowest density of all the phases. Now that we've reviewed the phase, let's talk about what happens and what words we use to describe the different phase changes. When we go from a solid to a liquid, we call that phase change melting. And when we go from a liquid to a solid, we call that freezing. Now, a liquid to gas is called vaporization, and a liquid is condensation. The last two phase changes, I think, are the more difficult of the six. This one I'm going to talk about is solid to gas. That is called sublimation. And then the last one, gas to solid, which is deposition. And if we draw these, here's a picture that is commonly used. If we have gases, let me get my pen on here. Gas to solid, or solid to gas is sublimation. You will see that sometimes when you open the freezer, and then the water will sublime into the gas phase, and you'll see that steam coming out of the dryer, or out of the freezer, sorry. The other ones, the next slide we're going to talk about is this one here, vaporization. A lot of people will call that evaporation, and there is a distinct difference between the two. So evaporation versus vaporization. Evaporation is very, very specific. It only occurs at the interface between a liquid and a gas. Typically that gas is air, but it doesn't have to be air. But just I want you to realize that evaporation only occurs at the surface. Okay? Vaporization is any phase change of a liquid to a gas. We'll also call it boiling. When you put a pot on the stove and the pot of water starts to boil, the first place where you see these little bubbles form is on the pot at the bottom. Well, that happens to be where the water is the highest temperature. And those little bubbles, they are not air bubbles. They are steam bubbles. They're bubbles of vaporized water. Okay, so boiling, vaporization does not have to occur at the surface. If you have a pot of boiling water, the vaporization is actually occurring at the bottom of the pot. The other thing that I want to talk about a little bit is vaporization occurs. It's defined as when the vapor pressure of the liquid is equal to the atmospheric pressure. And I put atmospheric pressure in quotes here because what I want you to realize is I just want you to know that it's the pressure that the liquid is being exposed to. Now we can increase the pressure or decrease the pressure. The other thing that I want to say is if you look on the boxes, they'll have directions for high altitude cooking. Well, what happens is that at high altitudes, the atmospheric pressure is lower. So that means that the water will boil at a lower temperature, which means that you have to cook things longer because it's not as a high enough temperature as it is at normal altitudes or normal elevations. Okay, so vaporization is defined as occurring when the vapor pressure of the liquid is equal to the pressure that that liquid is exposed to. And most commonly we call that atmospheric pressure. All right, the other thing that we can say is we can classify these phase changes into endothermic and exothermic phase changes. And when we have an endothermic process, that means it's absorbing energy or that we need to add energy or put energy into that phase change. So the first phase change that we're going to talk about that is an phase change is melting. So if you think about what happens if you have an ice cube and you heat it up, we're adding heat to it, and it will melt into liquid water. And then if we keep adding heat, and we get it to where the vapor, till it starts to boil, then we'll go under vaporization. And then the other one is sublimation, going from a solid to a gas. The other thing that I want you to realize is that solids we think of as having relatively low levels of energy and gases having high levels of energy. So endothermic processes will add that energy to put that phase of matter at a higher state of energy. Now, exothermic processes, they are ones that release energy or give off heat. Expect that they would be the opposite phase change from the endothermic process. So exothermic processes, exothermic phase changes, include freezing, which is going from liquid to solid, condensation, going from gas to liquid, and deposition, going from gas to solid. One last thing that I do want to talk about is something that the body does for itself to help regulate the body temperature, and that is sweating. So when you exercise or you get hot, you need to remove energy from your body to keep it from getting overheated. And so what happens is you sweat, and then the sweat is a liquid. And then actually the sweat is evaporating because it's happening at the liquid gas interface, or the liquid gas interface on your skin and the air. And so it is vaporizing, and it's going from a liquid to a gas. Now that process does require energy, and that energy comes from the human body, therefore helping to regulate the temperature of your body if it gets too hot.